So to achieve the Cartesian coordinate right-handed axis system, um, so we just fired for Maya, and just to elaborate the right-handed axis system, I just create a PDF file to elaborate my stuff. So the Cartesian coordinate is also called the right-handed axis system. So let's say if you hold your hand in such a way that your thumb points towards the positive y-axis, which is upward, the middle finger points towards the positive y-axis, uh, and the index finger points along the positive z-axis. So you can see this image clearly represent x, y, and z. Uh, so in Maya, what I did actually, I created the layers for the Cartesian coordinate system. Let's say this is your thumb, index finger, and then the middle finger representing the index finger, and the middle finger representing the x, y, and z. This could be you can explain this thing as well while having a negative x-axis, which means everything is being downwards right now. So your thumb goes upside down, which means negative y, negative x, and negative z. So let's just take a moment. We'll go back to our positive axis, and then we get a cube here at the moment. So by getting the cube, so the cube has its location here, which has a scale factor of 2 to 2. And so this is basically the Cartesian coordinate system. If you go back to this thing, we um, to get a better understanding by placing a cube at 0, 0, 0, x, y, z, which is a positive and negative axis respectively. So this represent we put the cube at the same location, but the negative axis, negative axis, and this is on the positive axis. So this is just turn on the both the layers to get this view, which is this figure 5, which shows positive and negative axes having a cube at 0, 0, 0. Now to get the cube shape, we can what we can do, we can get this by changing and moving the vertices of the cube um, um, which we call as a transformation. You can see the changes here. You can, sorry, you can check the attributes here when you move the cube. Let's say if we do it here, we just hide the layer, go back to this vertices, press F to see, and then if you what we'll do, we'll see this now. Yeah, you see as I'm moving this vertices, this is keep changing. So that's how you can change the vertices in Maya, by changing the vertices of the cube. So let's go back to our thing. Yeah, so yeah, so that's our right-handed axis. So the next thing is the how to add and subtract vectors in Maya. What I did actually, addition subtraction of vectors. So basically you will have two vectors, let's say A vectors, which has a head and the tail, and the vector B, which is going towards this direction, which has a head here and the tail. You can see the annotation here as well. So in such a way that the head of A will be at the location of 666 ordinates, and the B and the tail is 444, and the B head is 252, and the tail is 135. So this is a perspective and aerial view of the same two vectors in Maya. Now for to get the addition of vectors, we can achieve by placing a tail of a vector B to the head of the vector B A, resulting a new vector C can be formed, which we can say that vector C is equal to A plus B. So what I did actually, if you go back to Maya, just duplicate this layer, and then you see I just placed this piece of this whole vector of B on top of the on the head of the of A. So I just switch off this original vector B, so which results in vector C like this going towards direction. Um, if you go back here, so that's the aerial view or the top view, and that's the perspective view of A. The tail of B is on top of the head of A. So you get the vector C like this. So now what we did actually, we do what we'll keep these original vectors A and B. We'll do the reverse. Just trying to prove that A plus B is equal to B plus A in vectors. So the head of the vector A will be placed now on the tail of the vector A will be placed now on head of B. So what we do, keep this layer and duplicate our vector A like this. So you can see the original vector A is just placed over here. Now when we add these two vectors, we will get a vector D. Now you see the vector D. The result will remain the same if you add the vectors in either way. Showing the previous slides, vector C and D will have the same magnitude and direction. The same direction. We can switch off these layers. We will open up the C layer. You can see this C and D will have the same direction and the same magnitude. So which prove that A plus B is equal to B plus A in vectors. Now we'll go towards the subtraction of the vectors, which can be achieved by reversing the components of vector B to produce the equal and opposite vectors, and then placing the tail of the vector B to the head of the vector A, resulting in a new vector say is equal to A minus B. So basically, in subtractions, we are going to prove that A minus B will not be equal to B minus A. So if you go back to our thing, in Maya, and then we will have a vector B. So what we did actually, basically reverse, that was our thing, the vector. So we place the head of this vector to the head of a vector, reversing the components of vector B to produce the equal and opposite vector, and then placing the tail of vector B to the head of vector A. So basically we reverse it, we just reverse it, this vector, and place it over here to get this vector E, which is going in that direction, as you can see it over here. Perspective view of vector B. So to get the B minus A, we will reverse the vector A. Now A is like this, so we will reverse it and place the tail of the vector A to the head of vector B, such that the B minus A will get another vector F. So that's the top view and the perspective view of the B minus A. In this way, vector E and F will have the same magnitude but in the opposite direction. So we can switch off all the layers and we'll open up E and F. Sorry, now. So you can see clearly that vector E and vector F has the same magnitude but they're going in opposite direction. So I created the multiple layers for addition and subtraction. Next thing is the unit vector, how to get the unit vector in Maya. So let's say we will have a vector A. We will have a vector A here which has coordinates of 666 and We'll check it here. So basically a unit vector is a vector which has a magnitude of 1. Consider a vector such that the vector head is 666, which is showing here, and then the tail is 444. Now the component of the A will be like head minus tail, which will be this. So the magnitude of A will be the square root of 2 square plus 2 square plus 2 square, which is 12. So if you get the common factor, will be 2 root 3. So the unit vector will be 2 over 2 root 3, 2 over 2 root 3, or 2 over 2. So unit vector, you take the square root of that for the whole thing, the x component, y component, and the z component. It will come up as 1. So the unit vector which has a magnitude 1. So that's the thing. That's the head. That's the tail, which is 666 and 444. So that's the unit vector. The next thing is the length of a vector. Length of a vector can be achieved by getting the magnitude of a vector by Pythagoras theorem, which is the square root of the components of x, y, and z squared and added together. So imagine a vector. Consider a vector which has coordinates of this A, which is the head, and the tail of this vector is 4 over 4. The components A will be 2 to 2. So the length of the vector will be the total length of the vector will be under root 12, which is 3.46. So as you can see it here, so that's the head, which is 6 comma 6 comma 6. This is the tail, 4 comma 4 comma 4. When you get the magnitude of this vector, which will be defined as the length of a vector, in this case it will be 3.